Okay, welcome back. This is now 7.4 Systems of Nonlinear Equations. Expand the screen here. And here we'll have two methods as well. Again, just like with the systems of two equations, two linear equations, you'll have the substitution method and the addition method. Maybe even before I begin, though, just some words of help, things I've learned from doing these. First, avoid fractions if you can. Secondly, avoid roots. Avoid taking the square root on both sides if you can. And then thirdly, usually visually spot check your solutions. Okay. The problem is you'll get, as you go along in math, you get more and more equations, and it becomes more and more of a complicated process, especially if they're nonlinear. And sometimes you'll forget, oh, I had x equals 0, has to equal 0 somewhere, and I forget about that. And if I don't visually spot check and kind of exclude that, it's a nightmare. You get in a lot of trouble. Okay. Right, so let's take a look at, we have two methods again. We have the substitution method and the addition method. So the substitution method first, let's look at problem 3. Look at x plus y is 2, and then y equals x squared minus, 4x plus 4. You can usually guess, if you know what these things look like, how many solutions there will potentially be. I mean, visually, one of these things is a line with negative slope. The other thing is a parabola. So either the line is going to miss the parabola and you're going to have no solutions, or the line will just barely touch the parabola, in which case you'll have one solution, or you'll have two solutions if the line goes through the parabola. Okay. So you can kind of do a check that way and not have to worry so much. So if you get like 4 solutions, you know something's wrong, right? Okay. So anyways, the substitution method, I'm going to take one of the equations and solve it, and probably the easiest one to solve, in my opinion. Well, the second one's already solved, so you could use that, but I'm going to just solve the first equation. I'll work with that guy first. Then I'm going to take that expression and sub it into the unused equation. So sub that into the polynomial. 2 minus y squared minus 4 times 2. Wherever you see x, you're putting 2 minus y plus 4. Then I got some FOILing. 4 minus 4y plus y squared. I have to distribute. Minus 8 plus 4y plus 4. So y equals, start combining like terms. 4y minus, that's 0. I have a y squared. I have 4 plus 4 is 8. Minus 8 is 0. So I got y squared equals y. Do not divide. Okay? If you divide, you are potentially losing a solution. When you divide, you assume y is not equal to 0. Okay? And you know what happens when you assume things, right? Okay, so don't divide. So much to remember. Instead, what you do is set the thing equal to 0, so I'll have y squared minus y equals 0, and then factor it. And then set each part equal to 0, so y equals 0, or y minus 1 is 0. So y is 0 or y is 1, and then we could back sub to get our other solutions. So I'm going to borrow this equation. Looks like it'll work the best. Okay, so x will equal 2 minus 0 in the first case, in other words 2. So one solution, 2, 0. And then over here, x equals 2 minus 1. So my other solution is going to be 1, 1. And then I recommend going back to the original equation and just spot checking, make sure both ordered pairs work. So 2 plus 0 is 2, first one works. 1 plus 1 is 2, first one works. And then 2 squared is 4, minus 8 is negative 4, plus 4 is 0, that works. 1 minus 4 plus 4 is 1, so 1, 1 works, and that's our solution set right there. Okay. Okay. Let's look at another. So x squared plus y squared is 25, and then x minus y is 1. Okay, so the line, it has positive slope. If you had y equals negative x plus 1, you would see that. Or sorry, y equals positive x minus 1. So that's positive slope. What is that other guy? That guy's a circle. So again, it's a circle with radius 5. So again, there's either 0 solutions if they don't hit each other. There's 1 solution if the line is what they call tangent. Okay. Or there's going to be 2 solutions if the line goes directly through the circle. Okay, so at least right here, the geometry is elementary enough that we can kind of have a little bit of, confidence that our solution is correct. So if we get 3 solutions, we know we screwed it up. Okay, so again, I'm going to solve the second equation for one of the variables. I'll solve it for x. Substitute that into the other equation. And note, I'm not going to try to start with this equation of a circle because that's going to result in a square root. If you tried to solve for y here, you get y squared equals 25 minus x squared, and then you get y equals plus or minus square root of 20. So you end up with 2 new equations, and it's like it's gotten worse. I went from, 2 equations to 3 equations. All right, and you just don't go there. Just avoid those square roots if possible. Okay. All right, so anyways, y squared, I'm foiling 2y plus 1 plus y squared is 25. I got to set it equal to 0. Move the 25 over. I'm going to factor out a 2 and then divide both sides by 2. So I get y squared plus y minus 12 is 0. Factor that thing. It's 4 minus 3 is 0. So y is negative 4, or y is 3. And then get the x coordinate. X is y plus 1. So x is negative 3, or x is y plus 1. X is 4. Okay, so our potential solutions, I'm looking at negative 3, negative 4, and then 3, 4. Okay, and I spot check those in my equations. Negative 3 minus negative 4 is negative 3 plus 4, which is 1. 3 minus, that one didn't work. So I know I screwed something up with this because it's not working in this equation. 3 minus 4 is negative 1. So what did I screw up? Oh, x is 4, y is 3. Sorry. So good thing I checked, right? Okay, so then that would work. 4 minus 3 is 1. Then if you put it into the original equation, it's negative 3 squared is 9, plus 16 is, it's 25. 9 plus 16 plus 9 is 25. Okay, so that is my solution set right there. Okay, can there be any other solutions? Well, no, geometrically, no. The maximum number of solutions here is 2. Let's look at another one. So we have 13. xy is 3, and then x squared plus y squared is 10. That first equation automatically tells us that x can't be 0 and y can't be 0. What does it look like? It's one of these things, right? It's one of these guys with an asymptote. Because if you rewrote it, it would be y equals 3 over x. And this is basically what y equals 1 over x looks like. You multiply it by 3, it's kind of the same thing. The other guy is a circle. Okay? So how many solutions are possible? Well, there can be 0 solutions if the circle is small and kind of sitting in between it. There could be 2 solutions if the circle is barely touching these 2 branches. Or there can be 4 solutions if the circle is really big. So 1, 2, 3, 4. Okay. So geometrically, those are the only possible scenarios. So let's take a look. So first, I'm going to work with the rational equation. I'm going to assume that x is not equal to 0. It just can't be 0, because if you put 0 into this first equation, it wouldn't work anyways. It would be a false statement, no solution. So x can't be 0, so I can divide by 0. I get 3 over x. I'm going to take that guy and plop him into the other equation. So I have x squared plus 3 over x squared plus 10 equals 10. Okay. And then I have x squared plus 9 all over x squared equals 10. This is a rational equation. How do we solve these? Multiply both sides to get rid of the fractions. Okay, so we want to get rid of that second term, this fraction here, so multiply by x squared on both sides. So if I distribute, I'll get x to the 4th plus 9 equals 10x squared. That thing, you want to set it equal to 0. It has a quadratic form, believe it or not. So we can factor it. So I'll have, this should be x4, sorry. X squared, minus, 1 will be 9, the other one will be 1. Okay, and then set those equal to 0. X squared equals 9, so x by the square root factory, plus minus 3, x square root factory, x equals plus minus 1 on the other one. So it looks like we're getting 4 solutions. So let's go x equals -3, and I'm going to plop it back into this equation that I just boxed in red and put an arrow next to. 3 over -3 is -1 for y. Let's do, sorry, I put that in red. X equals +3, so that would be 3 over 3, so y is 1. Then x equals -1, so 3 over -1 is y equals -3. And then x equals +1, 3 over 1 is y equals 3. So it looks like we have the 4 solution case. Let me write those up. -3, I'm writing it at the left top. -1, 3 comma 1, -1, -3, and then 1, 3. Okay, and then I visually kind of just spot check them all. The product of these is both 3. The product of the x and y values has to always be 3. It looks like they always are. And then the square of both of them have to equal 10. Okay, so 9 plus 1 in each case, and they all work. Okay, so that's our solution set. Let's do one more, and then we'll scooch on over to the addition method for a little bit. So 17. We have x plus y equals 1, and then x minus 1 squared plus y plus 2 squared equals 10. Okay, so first, I'm going to solve that first equation. Avoid the second one because I don't want square roots. So I'll solve it for, I guess, x. So x is 1 minus y. And then substitute that into the other equation. So we'll have 1 minus y minus 1 squared plus y plus 2 squared equals 10. Simplify. 1 minus 1 is 0, so I just have minus y squared. And then I'm going to have to FOIL this next guy. And then I have 10 on the other side. Negative y squared. Negative y times negative y is y squared. FOILing, I get y squared plus 4y plus 4 equals 10. So I have 2y squared plus 4y, subtract the 10 from the other side, negative 6 is 0. Factor out, divide both sides by 2, so y squared plus 2y minus 3 is 0. Factor that, y plus 3, y minus 1 is 0. So it looks like y is negative 3, and then y is 1. I can plop that back into this equation over here in blue and quickly get x. So x is 1 minus negative 3 is 1 plus 3 is 4. And then 1 minus 1 is just 0. So my potential solutions, 4, negative 3, and then 0, 1. Now I want to spot check them. 4 plus negative 3 is 1, 0 plus 1 is 1. 4 minus 1 is 3, that'd be 9 plus 36. Ooh. No, it's negative 3 plus 2 is 1. Negative 3 plus 2 is negative 1, negative 1 squared is 1, 9 plus 1 is 10, so that's good. Then negative 1 squared plus 3 squared, it's going to be 1 plus 9 is 10, so they both work. Okay, and can there be any other solutions? Well, if you think about the geometry of it again, the second guy is a circle located at 1, negative 2, with a radius of root 10, which is like 3 something. So it's going to look like this. And then x plus y equals 1 is just a line like this. So it should go through 0, 1. You could literally see it on the graph. And then 4, negative 3. So there's 2 intersects. So I think we're good. Let's try the addition method. Okay. Right. So you'll kind of be able to tell when this addition method is a good idea. For example, this one. And again, the addition method, you add column-wise, and you want to see if there's a cancellation between variables. Okay. So here, if I add column-wise, you'll see the y's cancel, and you'll be left with 2x squared equals 18. And you'll be able to solve for x. Okay. The geometry of this one, the first equation is a circle. You guys are all familiar with that. But that second equation is something you're not so familiar with. It's called a hyperbola. Okay. And so it'll either be like this with it always has 2 branches, or it'll be moved out a little bit like this, where there'll be 2 solutions, or it'll be way out here and there'll be 0 solutions. Okay. So there'll either be 1, 2, 3, 4 solutions, or 2 solutions, or 0 solutions. Okay. Anyways, here we go. X squared, 18 divided by 2 is 9. Square root property says we get plus minus 3. Okay, so x equals 3, x equals negative 3. Then we got to use one of the equations, so I'll just use the first one. X squared is 9 plus y squared is 13. So we get y squared is 4, and then y is plus minus 2. So it looks like we have 2 solutions there. And then on this other guy, it'll also be 9. Negative 3 squared is 9, plus y squared is 13. Y squared is 4. So y is, again, plus minus 2. So we get 4 potential solutions, 3, comma 2, 3, comma negative 2, negative 3, comma 2, and then negative 3, comma negative 2. And I spot check them all. So 9 plus 4 is always 13. Those always work. And then 9 minus 4 for all of them. You square them all, that's always going to be true. So those all work. And there's our solution set. Let's get 4 solutions. Let's try another. Y squared minus x is 4. And then we have x squared plus y squared is 4. Okay. Again, you could do addition method, try to get those y squares to cancel. First, I'll just rewrite it. So I got negative x plus y squared equals 4, and then x squared plus y squared is 4. Then I can multiply either the first or the second equation by negative 1. I'll just do the first one. So I get x minus y squared is 4. and then x squared plus y squared is 4. The geometry of this one, you have a parabola and a circle. Okay, and the parabola is a little unusual in that it's if you solve it, it'd be x equals y squared, right? Y squared minus 4, and the orientation then would be like this, okay, but then shifted over 4. So 1, 2, 3, 4, I believe, and it would, I believe it looks like this, okay, and then you have a circle, so there's no way I have it right then. Maybe it's pointing in the other direction. So if I move that and then move the 4, when x is 4, sorry folks, I went in the other direction, I went in the wrong direction. Yeah, should be over to the other side, sorry. Kind of weird when everything is sideways. So that thing will look like this, 1, 2, 3, 4, look like this. Okay. And then we have a circle. So when x is 0, y will be plus or minus 2. So 1, 2, 1, 2. And we have a circle going through here, like this. And it looks like it's just going to hit it in 2 places. Okay, maybe it kind of bounces out a little bit and then comes back in and goes through like that. Okay, that could be the case. I'm not sure. Okay, so it's either 2 or 4 solutions. Let's take a look. Okay, so I can add these up. I'll get x squared plus x equals, I guess I should have had 0 over there, right? So if I multiply the first equation by a negative, this will be negative 4. So negative 4 plus 4 is 0. Okay, so then you can factor out an x, and you're going to get x is 0 or x is negative 1. And then I'm going to back substitute. So when x is 0, I'll have negative y squared equals negative 4. So I'm just using this equation. You can basically use any equation so long as it has x and y in it. So y squared equals 4. In other words, y is plus or minus 2. Okay, so that would be this point and this point. And then it looks like there's some more points, right? Negative 1. So it does kind of go out a bit. So let me redraw it so it's a little nicer. 2, 3, 4. So the circle will kind of go out like that. Okay, and you'll get these 2 intersection points, but you're also going to get these 2 weird ones over here. Okay, so x is negative 1. I'll have then, negative 1 minus y squared is negative 4. So negative y squared is negative 3. So y squared is 3. So y is plus or minus root 3. And so it looks like my solutions, 0, it looks like there's 4 of them. Let me just keep them all up here. So 0, 2, 0, negative 2, negative 1, root 3, and then negative 1, negative root 3. And I want to check them all. Hopefully that will be my solution set. Okay. So if I put them in this equation, 4 minus 0, 4 minus 0, that works. 3 minus negative 1, those would be 3 plus 1, 3 plus 1, those work. In the second equation, 0 plus 4, 0 plus 4, 1 plus 3, 1 plus 3, those all work. So there's my solution set, and let's go on to an application. Okay. So number 62, we're building a box, and this is on page 852. So they give you a piece of paper or a cardboard or something, and they tell you the area of that cardboard is 216 inches squared. Okay, so it'll have some x and y. Then you're going to take the corners and kind of cut them off so you can fold up the sides and make a little box. Okay, so I'm going to cut these corners off. And the dimensions of the corners are all the same, 2 by 2. So this distance here is 2, and this side, this distance is 2. So this will be 2. And then you fold up the sides to make a box, and of course that box will look like the following figure. More or less. Okay. So we want to figure out what is the x and y. They also tell you that the volume of the box is 224. Okay. So from the area and the volume, we can figure out some equations and build a system of equations. So the area equation, is x times y equals 216. So I got one equation. Okay. And then for the volume is going to be this length here, okay, for the base, and that's what, x minus 4. Okay, so the base length is x minus 4, and the volume is just base length times base times height. Okay, so that side is x minus 4 units. This side here is then y minus 4 units, because this is 2. So x minus 4 times y minus 4. And then finally, the height of the box is 2. Okay, so times 2, and that should equal 224. Okay, so we have a nonlinear system. Let's go ahead and first I will solve that first equation for, I guess, x or y. And we know they can't be 0 because the side of a box isn't going to be 0 units. So I'll just solve for y. It's 216 over x. And then I'll dump that into the unused equation. Let me go ahead and clean this up a bit. So this will be 2 times xy minus 4x minus 4y plus 16, and then if I equals 224, then if I distribute, it would be 2xy minus 8x minus 8y plus 32 equals 224. I'm going to move the 224, I guess, to the other side, or divide everything by 2, so you get xy minus 4x minus 4y plus 16 equals 112, and then move the 112 over, I guess, if you wish, and you're going to get negative 96. So xy minus 4x minus 4y minus 96 is 0. Okay, so finally then I'm going to take this equation, or this expression, and plop it in for y, wherever I see y. So I'll have x times 216 over x minus 4x minus 4 times 216 over x minus 96 is 0. So the x's cancel on that first one. You get 216 minus 4x minus, I think, 864 over x minus 96. Then I can combine some like terms. It's equal to 0. What do I have? So 216 minus, I'm a little worried. I was kind of did some of these calculations in my head. Let me make sure. 112, 16, 12, 6, 96. Yeah, that one's right. 216 minus 96. 0, 120. So 120 minus 4x minus 864 over x equals 0. I think I could divide everything by 4 and it would be okay. So I would end up with 4 into 120 should be 30, minus x minus 4 into 864, 2, 8, 6, 1, 4, 2, 4. So that would be 6, 216, 216 over x is 0. It's a rational equation, so we want to multiply both sides, get rid of the denominator on that third term there, on this term. So multiply by x on both sides. Okay, so you get 30x minus x squared minus 216 is 0. And then let's move everything to the other side so it's easy to factor. X squared minus 30x plus 216 is 0. And then you may have to play around with this a bit, but you're going to get x minus 12 and x minus 18, if you do it right, is 0. So either x is 12 or x is 18. So if x is 12, then y will be 216 over 12, which is, of course, 18. If x is 18, then y will be 216 over 18, which, of course, is 12. So we want the length to be 12 and the width to be 18. And I think these are in inches, so 12 inch and the width to be 18 inches. Okay. Okay, so that's an application. And that'll pretty much do it for this section. We'll call it quits, and we'll see you next time. Okay, thanks for watching.